Okay, in the last week, we talked about how to describe and show data with graphs. We did histograms, bar charts, pie charts, etc. Here we're going to talk about mathematical ways to describe these quantities, and we're going to start with measures of central tendency, okay? So kind of three different ways that represent the center of data: means, medians, and modes. So the first one, and again, I think people have heard of these before mostly, but we're going to talk about what exactly they are, when to use them, and how to calculate them. We will be doing some things by hand, or you can use computers if you want. Geogebra, there's a link in the module for this Geogebra website, and we're going to introduce how to use this website as well, which can make a lot of calculations much easier. There are many ways that you can do these calculations though. Okay. So we're going to start with the mean. The mean, called mu, so this right here is pronounced mu, and it's written mu. It's a Greek letter, and it's pronounced like the Pokemon. All right. Anyway, that mean mu of the set of data is the sum of all the data values divided by how many data values there are. Sometimes this number of data values, we'll call that n. Okay, so add up all the data values, divide by n, how many there are. It's also known as the average. Sometimes it's called the arithmetic mean. Average is very, very common. And then, usually we'll use the word average as well. And the mean always has the same units as the original problem. And we'll get into what that means later. So let's do an example. So we're revisiting an example from the last week, example 9.8. We had data of 16 randomly selected weights of models, I think, for some model agency. And these weights are all in pounds. Models from a model agency. Great. Find the mean and interpret your answer in the context of the problem. Okay, so we just have to add up all these values and divide by how many there are. So n is how many data values there are. This is 4 by 4. 4 times 4 is 16. There are 16 data values here. So we're just going to add them all up. So mu, our mean, is going to be 110 plus 138 plus ... We're just adding them all up. So I use the ... and then I skip to the last one if my head doesn't block it. All right. And then divided by n, which is 16. So type all of these into a calculator, add them all up, and be very careful that you're dividing the whole thing by n. Here's another way of doing this. So we can use our calculator and type this in, but you can also use Geogebra. All right, so what you can do is use a computer. And so what I'm going to do is I'm going to do this one of two ways, depending on whether it will let me select this text. Okay, so it doesn't. What I'm going to do is just manually type these values into Geogebra. You can also a lot of times copy and paste. So 110, 138, 98, 110, 85, 98. And just type in all of these values, or you can copy and paste. And a lot of times it will be copy and pasteable. And then what we're going to do is click and hold to highlight all of the values. You can also just choose the column, and then I'll highlight everything as well. Click on this histogram up here and choose one variable analysis. This is going to automatically create a histogram for you. And that's what we did last week, created histograms. This is one way that you can create histograms. And specifically for this week, what we're going to be curious about are these statistics up here. So click on this Show Statistics button, this sigma x, and it will tell you n, the size, our sample size is 16, just like we said. And it tells you that our mean is 106.0625. It tells us a whole bunch of things about this data. But right now we just want the mean, 106.06 approximately. Let's round here. We're going to go to our notes. and say the mean is about 106.06. What are the units here? The units are the same units as the original data value, pounds. Find the mean weight of the models. We did that. And interpret your answer in the context of the problem. We're going to say the average model at this agency is about 106 pounds. And that's the interpretation. There are two parts to our answer here. And that's how we do it, both by hand and with Geogebra. We can do this again with the next example. And the next example wants us to find the mean from a frequency table. So this is a little different. So say we find the mean weight of the models using a frequency table. Remember, this is a frequency table with 1, 2, 3, 4, 5, 6 class intervals. All right, and so this is going to be hopefully the same as what we had above. Remember, we did make a frequency table like this last week. Well, how do we do it this way? N is still 16, right? It's just all of the frequencies added up together. N is still 16, but now we're still adding all of the weights. So we're still adding all the weights, but now instead of just adding up 85 once, we have 4 of these 85s. We have 85 plus 85 plus 85 plus 85. But, right, if you have 4 85s added together, we don't have to write it like this, right? That's just 4 85s. So 4 times 85. So that's what we're going to have here. 4 times 85 plus 2 times 98 plus 1 times 100 plus 4 times 110 plus, I'm running out of room, 3 times 115 plus 2 times 138. And divide all of these by n, which is still 16. Type this into a calculator, you should get the same exact answer. 106.06 pounds. All right. And that's how you do it with the frequency table. If you wanted to do GeoGebra with the frequency table, what you could do is you could just type in, well, it said there's 4 85s. So let's just type 85 in 4 times. Said there are 2 98s, we type in 98 twice. There's 1 100, type that in once. There's 4 110s, so type it 4 times. There are 3 115s, and there are 2 138s. Select the column or highlight the cells individually. Click here, one variable analysis. Up here, show statistics. Should be the same mean. Okay, these are the same data sets. One was created from a frequency table, and one was created from the raw data. All right. So last thing to mention in this video, sometimes we have data that's really, really far outside the primary grouping. So maybe there's a whole bunch of really, really low weights, and then maybe there's a data value that's either really high or really low. And this value we call an outlier. Now, in a lot of statistics, we have ways of calculating outliers. What is an outlier? What's not an outlier? We're not going to worry about that too much here, but you should know what it means. It just means something that's kind of really outside of the data. And sometimes they're from errors. Sometimes they show something significant about the population. It depends. But be aware that outliers can have a big influence on the mean. Okay, they don't have as big of an influence on the median, which we haven't talked about yet. They have a big influence on the mean. Large values, large outliers can influence a larger mean, and a small outlier can influence a smaller mean. That wouldn't be a true reflection of the given data set. So be very careful when you have outliers when talking about the mean, and just be aware of its effect. All right, that's the video. Good luck doing mean stuff.